Creating a full set of dependency rules for a large project is both tedious and error-prone. Messing up even one dependency, especially with respect to a header file, invites occasional missed recompilations of the affected source file with attendant subtle bugs. In this segment, we'll briefly review wildcard makefile dependency rules and automatic generation of makefile dependency rules. Now, listing a dependency rule like that on lines 15 through 16 for every .o file in a large project can be pretty tedious. One simple way around this, at least for simple cases like making x.o dependent on x.c, is to use pattern-based wildcard dependencies, like that on lines 26 through 27 here of our sample makefile. Now, this percent sign is a wildcard. So the rule makes any file x.o, whatever it might be, dependent on a corresponding file x.c, where x can be any string. In the build command, you can use the awkwardly named $sign <= for the matched dependency file and $@ for the matched target file. Another good wildcard rule would be to show each .c file as dependent on its corresponding .h file, like on lines 29 through 30 here. The build command for this rule uses touch, as discussed in the prior lecture. And of course, C files are often dependent on more than just their corresponding H file, so we'll still need rules like that on lines 18 through 19, which enforces the dependency of lzw.exp.c on all the other .h files that it includes. System files, by the way, like standard.io.h, are assumed unchanging and thus rarely included as dependencies in a makefile. Now, to get automatic rules like this, more complex ones, we need rule-generating software. Any tedious, error-prone task like makefile rule dependency generation is best done by automation. And it should be possible to scan a C source file for #include statements and deduce from these the header files on which the C source file depends, creating a dependency rule from them. I could tell you that there's a well-accepted standard tool for generating dependency rules from C source files, but I'd be lying if I did. Instead, there is a profusion of different tools, from a very primitive make-depend utility in Unix, up to sophisticated handcrafted scripts, often written for larger projects. Generating makefile dependency rules seems to be the sort of task that everyone thinks they can do a bit better than the existing tools. And keeping with this tradition, we'll build a small example script of our own to show how such tools work. Now, that script is down here. Making our script work is going to be greatly simplified by the fact that the GCC compiler that we use in our examples can help with this task. Given that the preprocessor is already checking for #include directives, it makes sense that a C compiler might offer some assistance in generating makefile dependencies, and most dependency rule generators rely on compilers to do much of their work. The command gcc-mm and any C file prints out the first line of a dependency rule for that file. Let's try it out here briefly. Got a directory with a bunch of C files relevant to the project we've got a makefile for. I'm going to do gcc-mm and lzw.exp.c, and there you go. Now, note that the generated rule is actually for the .o file that would be created by compiling lzw.exp.c, with lzw.exp.c and all header files shown as dependencies. This is an alternative to showing the .o.c and .c.h dependencies separately, and it works just as well. All we need is the right build commands, and the GCC output will be a complete dependency rule. The small shell script in the diagram adds these. Now, this is not a lecture on shell scripts, but here's a brief summary at least. The for loop on lines 1, 2, and 5 iterates on I as a loop counter variable, setting it to each command line argument to the script in succession, and we'll run the script with .c files as command line arguments. Line 3 runs GCC with that -mm option on each .c file. And $i, by the way, is shell script notation for the value of variable I. The concatenate, greater operation, attaches the GCC output to the end of makefile. Now, line 4 runs the echo utility, which simply prints its command line arguments to output. Literally, in this case, $CPP, $CFlags -C, then preceded by a tab, as you can see, and followed by the current file name. Concatenating all that to the end of makefile. And note that's a tab, not spaces, before the $CPP, per the required syntax for indenting build commands. Now, running this, as you can see, we'll do it right here on a set of .c files, we'll add appropriate dependency rules for each .c file to the end of makefile. /add rules .c. And then when I bring up the makefile in a current editor, we can see that all the rules that we need there have been correctly added. I'll go back and add these to the diagram as well, and then let's comment out the older rules in favor of these newer ones, and then ask a question. What commands will make run, assuming that test.exp is currently up to date, if I run now touch lzwexp.h followed by just the command make? Track through all of the process we've talked about and the newly added dependencies and figure out what's going to happen in that case. And for the answer here, after the pause, recall that make without an argument builds the first target, which in this case is going to be test.exp. And touching lzwexp results in a rebuild of lzwexp.o per line 37, and of test.exp.o per line 43, but not of codeset.o, nor of smartalec.o, since neither of those depend on lzwexp.h. So the commands that will be run are gcc dash, with the flags up there, remember w and dash d little endian, gcc dash w dash d little endian dash c, lzwexp.c, same thing for test.exp.c, and then a grand gcc of all the .o files that are relevant to create the final test.exp executable. Now, anyone accustomed to an IDE, like Eclipse or Visual Studio, will no doubt find the awkward textual format of makefiles, the need for handcrafted dependency rule generators, etc., very old school and outdated by comparison with the highly automated build management of a modern IDE. At one level, this is a fair judgment, but it is remarkable how many large, complex projects eschew the simplicity of using an IDE in favor of creating their own build management tools, often using the tedious but highly flexible make command as a starting point, and then augmenting it with scripts to generate dependency rules and so forth. The reason for this is not attachment to old tools, but rather the fact that a sufficiently complex project almost always has subtle build requirements that are not accommodated by standard IDEs. These might include special compile flags needed only by certain targets, complex dependencies requiring script logic, or code generation steps that are performed via scripts. Also, very large projects can overwhelm an IDE tool, making it run unacceptably slowly. So, in the final estimation, using an IDE is fine, and even preferred for mid-sized projects with standard build requirements. But knowing how to use less automated but more powerful tools, like make and scripts, is sometimes indispensable.